Hello students. So in this question, they are saying there is a horizontal film of soap solution. On it, a thread is placed in the form of a loop. The film is burst inside a loop and the thread becomes a circular loop of radius r. If the surface tension of the loop is T, then what will be the tension in the thread? So actually they are saying that we have some soap solution, like suppose that we treat it as a square soap solution, and we have a thin film of soap solution here, and when we'll put a thread in this structure, when we'll put this thread loop in the soap solution, it will become circular due to surface tension. Why it will become circular? Because the soap solution film will try to pull this at all point outside. The soap solution surface tension will try to pull it outside, so it will stretch and become a circle. Same thing will happen if the thread is charged. Suppose that here this thread is uncharged, and suddenly we gave this thread is made up of conductor, some conducting thread, and suddenly we gave it some charge. So in the same case, charge will repel each other, and that this loose thread will become circle. So here, why it is becoming circle? Because there is some surface tension in the soap film, and that surface tension will try to pull all these thread towards the boundary, so it will become circular. Now the question is asking what will be tension, like when it is stretched. Here this thread is not stretched, but here this is stretched. So at any point, suppose that here, what is the tension in the thread? Means with what force this thread at this point is being pulled in this direction and this direction. We all know force will always exist in pair. So that tension they are asking. Suppose that here value of tension is T. So first of all, what we'll do, we will take a very small part of this circle, very small. Like how much small? Very small. Like the angle is almost d theta. D theta. The angle is almost d theta. Very small. Very small. Why we are taking a small? That is one of the question. So first we'll make that picture here. Suppose that this is the that part. So we are taking this small part here, and we can say we are zooming it. We are zooming it. So after zooming it, we'll get this picture of this one. Radius is r, so this will also be r, this will also be r. And one more thing, this will also be radius, but just we are extending it. We are extending it. Let's make this one also little. Why we are taking small? That is our small element. That is our first question. So we are taking a small element such that if we draw here a straight line joining these 2 points, that straight line is similar to this curved line. Means if we draw here a straight line like this, see here we have zoomed it, that's why this curved line and this straight line is different. But if it is very small, I mean, say we are saying that this angle is d theta by 2, and this angle is also d theta by 2. This total angle is d theta and very small. So for very small angle, this and this straight line and this curved part, both will be almost similar. Both will be almost similar. Now we'll check how much forces are acting. So net force on this part, this curved path, will act in upward direction, and it will be equal to force due to surface tension. Force due to surface tension, which is always equal to length, which will be, what will be the length of this curved path? It will be radius multiplied by total angle, which is d theta. So we can write r d theta. This is the length of this arc multiplied by surface tension, which is T. Call that surface tension T. And since there will be two surface, whenever there is some soap film, there will be two surface, one surface inside, one surface outside. Always remember, whenever we have any film, it will have two surface. If we have solid drop of any liquid, then we'll have only one surface, because inside we'll have solid volume, and outside only we'll have surface. If you go back to the basic understanding of surface tension, why surface tension act due to attractive forces, unbalanced attractive forces at the surface. So surface tension only act at surface. So since here we'll have two surface, one here which we are seeing on the screen and one from behind the screen. So any film, any layer have two surface, one upper surface, one lower surface, so multiplied by 2. This is the total force acting upward due to surface tension. This is the force due to surface tension. Now we all know tension will act in this direction here along this curve, and here also in this direction. Now we want to take its component along the direction where surface tension force is acting, means in opposite direction. So we want to calculate this component. Now we will learn why we have taken very small, like we have taken very small, so that this part and this part is same as this curve, means this straight line and this curved path both are same, so that we can take the direction of tension here along this straight line, which is actually not correct exactly. The surface tension will be along this curve at that point. Like here, what will be the sorry, not surface tension, at this point what will be the direction of tension? Here direction of tension will be along this direction, and here in this direction. But if we take that size very small, so very small, so we can say that that small line is equal to that curved line in length. Small straight line or curved line both are same. So here surface tension will be in this direction, and here also surface tension will be in this direction. Surface tension will be in this direction. Let me make it clear. Surface tension will be in this direction. Now if you calculate the angle, see, so now we want to calculate the angle at which this is acting. So actually we want to calculate this angle. See, this line, this straight line is almost tangent to this point. Actually, it is when we look on this, it is not looking like a tangent. It is looking like a segment. But since our that arc is very small, this arc is very small. That's why we have taken this arc very small. So this can be called uh, um, tangent to. Like suppose that on this circle we are taking a segment like this segment is big, so it cannot be called tangent. Take one more segment which is little smaller, one more segment which is more smaller. So when we'll take very small arc, the segment and the tangent both will be almost same. So here this line and this line can be called tangent to. So now this angle is going to be 90 degree, and if this angle is d theta by 2, and here this angle will become 90 minus d theta by 2. Similarly, this angle will also become 90 minus d theta by 2. And here in this direction we have tension T, which we are calling tension force. This is tension force. F T is tension force. So now what will be the component of Ft along this direction? It will be Ft cos 90 minus d theta by 2, means Ft sin d theta by 2. So this force is going to be Ft is equal to we have to calculate Ft. So actually what we will do, see what will be the force along this direction which will oppose the force due to surface tension. It will be Ft sin theta by 2, sin d theta by 2. And since one force here, one force here, see one more component of the force will be in this direction and one component will be in this direction, and this will be Ft cos theta, and this along the radius will be Ft sin theta. This side also along the radius will be Ft sin theta, along the tangent this will be Ft cos theta, and these two will balance each other. So total force will be 2 Ft sin d theta by 2, and this force will balance R d theta T multiplied by 2. So this is the force due to surface tension which is acting outward, and this is the force due to tension in the rope which is acting inward. So one component of ft, this ft and this ft inward is 2ft sine d theta by 2, and one component in this direction, this ft cos theta, and component of this part of ft will be here, ft cos theta, these two will balance each other. Now we all know when angle is very small, sine theta is equal to theta, and d theta we have already said that it is very small, so we can write 2 ft 2ft d theta by 2 is equal to r d theta t into 2. Now d theta cancel, 2 cancel. So from here we can write force due to tension, means tension in the string is going to be 2 RT. Tension. This is our tension. Tension in the string is going to be 2 RT. Same type of question will be asked in electrostat 2. There in that question there will not be any surface tension and soap solution, soap I mean uh, membrane, or what we call, yes, there will not be any soap film, there will be charge in this string or in this thread, and due to that charge it will be repelled outward. This is like a homework for all of you. Try to solve what will happen when we have some charge q on this um, thread. We have some, like the thread was in this condition, now suddenly we have given some charge q to this thread, so what will be the tension in the in that thread? Try to solve that. Thank you.